You are given the angle A equals 225 degrees. Part 1, calculate or the reference angle for A. Part 2, show cos of A sine of A and cos of R sine of R on a unit circle. Part 3, express cos of A, sine of A and tan of A in terms of cos of R, sine of R and tan of R using the unit circle. Part 4, using the formulae and tables to express cos of 225 degrees, sine of 225 degrees and tan of 225 degrees as exact values. So part 1, calculate or the reference angle for A. So remember the angle is 225 degrees and 225 degrees lies in the third quadrant. So this is our unit circle. We start at 0 degrees. We work our way up to 90 degrees, around to 180 degrees, and 225 degrees is about here. So it's in the third quadrant. This is the first quadrant, second quadrant, third quadrant. So if we're trying to find the reference angle in the third quadrant, it's going to be the angle minus 180 degrees. You have to learn this off by heart. So it's going to be 225 degrees minus 180 degrees, which is 45 degrees. So the reference angle is 45 degrees. Part 2. Show cos of A sine of A and cos of R sine of R on a unit circle. So part 2, the diagram opposite shows cos of 225 degrees, sine of 225 degrees, so right here, and cos of 45 degrees, sine of 45 degrees, right here. So remember we have our unit circle, the centre 0, 0. We have a radius of 1. This would be 0 degrees, this would be 90 degrees, so this must be 45 degrees. So this particular point is cos 45 degrees, sine 45 degrees. Moving around, we get to 180 degrees. And if we keep going to the southern part of the circle, we would get to 270 degrees. So halfway between must be 225 degrees. So this particular point is cos 225 degrees, sine 225 degrees. Part 3, express cos of A, sine of A, tan of A in terms of cos of R, sine of R, tan of R using the unit circle. As cos 225 degrees, sine 225 degrees is the image of the point cos 45 degrees, sine 45 degrees under reflection in the origin. So we can see this is the origin, this is the point, cos 225 degrees, sine 225 degrees, and it is a reflection in the origin of the point cos 45 degrees, sine 45 degrees. So as cos 225 degrees, sine 225 degrees is the image of the point cos 45 degrees, sine 45 degrees under reflection in the origin, then cos of 225 degrees is going to be equal to minus cos 45 degrees. And sine 225 degrees is going to be equal to minus sine 45 degrees. So tan 225 degrees is going to be sine 225 degrees over cos 225 degrees, because tan of A is equal to sine of A over cos of A. This comes from our formula book. And we can swap sine of 225 degrees for minus sine 45 degrees, and cos of 225 degrees for minus cos 45 degrees. And a minus divided by minus is a plus. Sine over cos is tan, so we get tan of 45 degrees. Part 4, use the formulae and tables to express cos 25 degrees, sine 25 degrees, and tan 25 degrees as exact values. So cos of 225 degrees we know is minus cos of 45 degrees. And if we look at our formula, so these are trigonometric ratio of certain angles. We look along the top row, we've got degrees. The next row we've got radians. And then we've got our cos, sine, and tan values. So we want to go to cos 45 degrees. So this row here matches up with cos of A. And this is 45. So 1 over root 2 is what we're looking for. Remember, we've got a minus in front, so we get minus 1 over root 2. Then sine of 225 degrees is equal to minus sine 45 degrees. So go to our sine row, and 45, and we get 1 over root 2. But remember, there's a minus in front, so it's minus 1 over root 2. And then tan of 225 degrees is really tan of 45 degrees. And tan 45 degrees is 1.